Hello friends, welcome back to the bench. Today we have something very interesting. This is a current sensor from Smart, Smart 2013 electric vehicle. I have a picture of it assembled to the engine, and it doesn't work. How do we know it doesn't work? The measurement that the customer said it should have, based on the measurements of the working device, basically there's two terminals. That's where the battery goes. I'm guessing the charging cable here, battery here, or the other way around. And these two pins react to the current flow between these two terminals. Now, between these two terminals and both of these little pins, we should have 2.8 mega ohms, right? And we have about 1.2, 1.4. There's about 1.5 on one of them. Oh, actually, hang on, I did it wrong. Between these two, about 1.4, 1.5, and the other one is 20 ohms. So we obviously have almost short. It's not a dead short, but it obviously has been damaged by the high current flow, I'm guessing. Now, under the microscope, right, this is the part. It's Bosch, made in Hungary. And as you can see, either Johnny, the owner of this, or someone on his behalf already tried to open it. And look how deep they ground through, and still nothing in, right? Nothing is coming loose. And this piece is assembled separately. It has a seam over here, right? And so this could be detached. We probably could break it apart with a hammer, but we don't need to do that. We wanted to see what's inside here in this little baby. But look how deep it already went over here, and still nothing. Right, and my tool is not even going to be as deep as this one. Look, huge depth, and nothing's coming loose, nothing's coming apart. So probability is that inside everything is doused in epoxy, which means even if we cut through it, there's still not much we can do with this. And I'm thinking that's the case because I did the acoustic test, right? You should hear a difference acoustically if it was empty inside. But pretty much everywhere it makes the same sound. Pretty much everywhere. So now, the only thing that the previous technician didn't touch is this part here, right? There might not be much electronics over here, that's why it's so full, and there's only tiny little thing underneath there. So maybe we can just cut through this. But as you can see over here, someone already tried, and it's not looking good. It is not looking promising. So what I will do is this. I'm gonna start cutting here around. Then, depending on what I see, I will just start removing this plastic. This, well, I'm guessing it's some kind of plastic. It's hard to say what it is. It's some kind of, it's very tough material. I tried heating it up. It is not reactive to heat. I tried about 200 degrees Celsius. It did not even make a dent. So this is highly resistant to heat. I was also thinking of perhaps if we just submerge it in acetone, maybe it'll just eat away some of this plastic and or make it soft, or maybe it'll just fall apart by itself. Very unlikely, but I might try that. So, without further ado, let's start drilling. For that, I'm not gonna use the what I usually use, which is the pen, the grinding pen. This is what I use for retracing and, you know, all the stuff you've seen on my channel before, but it's battery operated. This one is a lot lower quality. Very simple device, but it gets the job done. And it is not battery powered. It is powered by a I'm guessing 12 volt power supply. I never actually even checked. And I got these recently from Union Repair. And let's grab one of these. And see if we can just cut through it. We'll see what kind of mess it's gonna be making. Alrighty, so this is what we have. This is what happened to my bit. It's completely smooth now. See that? It is cheap Chinese bit, yeah, but I did not, and this is made for wood, not for materials like that. But this seems to be some kind of metal. It's not plastic or some kind of composite material. Who knows? But it completely destroyed my bit. Completely. What we found is this. So we have a copper element here, a copper element here, here, and that's it. So this is likely the depth. This thing, see here, this looks like a PCB. I'm not sure. This could be a epoxy, and it just looks like PCB. But suppose I keep grinding, which is going to take several hours. I keep grinding around here to just kind of discover what those elements inside are. Even if I do, there's nothing we can do. We can't fix it, right? There's not like I can desolder something or replace a component. I was really curious because I was thinking, how does it work? Perhaps there's like a big resistor or resistor array over here, and they are like 200 milliohms or, you know, like some very low resistance. And we're just measuring the voltage drop on this, but it doesn't appear to be a resistor here, right? So I ground through the entire path, and it looks like this is the single element, single copper connector. So I'm not sure how it works, but I do know that there's nothing I can really do with this. I could, as I said, I could just continue grinding, grinding, and maybe I will discover something. But even if I do, how do I know I'm not destroying something by doing this? Right, because I'm grinding through that copper as well. Right, so even if there's a transistor over here, say, then, you know, if I just grind like this through this material, I don't know when I'm grinding through the actual transistor or element that we need to, or a component that we need to fix. So I don't know, someone said that there is someone who fixes those, and I'm really interested to know how. Like, how do you fix anything in here? It's like if one solid element, one solid piece, no way to open it, and even after grinding through it, there's, how do we fix anything in there? So I think we're done with this. I might, if I have like really a lot of spare time, which I normally never do, maybe I will return to this and start grinding even more just to find out how it works, because that's just my curiosity. But it comes at a huge cost. Right now my hands are really shaky, so I'm not going to be able to do any more repairs today, or at least not in the next hour or two. Luckily I have some coding to do, so that's fine. But yeah, I think this is a defeat. I could not get this open. And I'm down one tool. I gotta order more of these. These are primarily for wood, so it doesn't surprise me that it gave out on this. But at least now we know how tough this material is. And actually those diamond bits, they work pretty well. They grind pretty well for this. So good to know. And that's like this, I don't know, set. Also really cheap Chinese set. Works great. I use it for engraving, which I don't do much lately. Not a lot of people like engraving or want anything engraved. Christmas time is more of a time for those kind of jobs. People want to buy some nice stuff and have it engraved for whoever. But not summertime. Surprisingly, it seems pretty busy because I'm waiting on 3 more ECMs. So that's kind of unusual for April. But I'm not complaining at all. Alrighty, fellas. Sorry you didn't see anything too interesting in this one. If I ever come back to this, I will definitely record it and share my results with you guys. Until then, thank you very much for watching, and I'll see you guys in the next one.